Assalamu alaikum. So today we are going to study sampling distribution of the sample proportion, which is the last topic of our chapter sampling. So this sample proportion is new to you. What is proportion? Proportion is it's not a complicated thing. It is just proportion or division of the items or the portion of items from the total. So let's read it. The sample proportion has different value in different samples. Sample proportion has different values in different sample. The probability distribution of the proportions of all possible random samples of size n is called the sampling distribution of proportion, that is represented by p cap. Now what is the proportion? Proportion is represented or denoted by p cap, and it is equal to x by n, where x is the number of favorable items in the sample and small n is the number of total items in the sample. So now, before this, we have discussed the sampling distribution of sample mean, in which we computed the mean of each sample, and then we computed the sampling distribution of mean. But here we are going to use proportion. Proportion are the is the fraction of the number of favorable divided by the total number. So here are again two main properties of sampling distribution of proportion. First property is the mean of the sampling distribution of proportion is equal to the population proportion, capital P. Population proportion is represented by capital P, and the mean of the sampling distribution of proportion is represented by mu p cap. So mu p cap will be equal to population proportion P, and the second property is about standard deviation. The standard deviation of the sampling distribution of proportions, denoted by sigma p cap, is given as sigma p cap is equal to whole under root p into q by n. Now p is the proportion or probability of favorable outcomes, and q is the probability of non-favorable outcomes, or we can say that this p is the probability of success in which we are interested, and q is the probability of failure in which we are not interested, and n is again the number of items in the sample, or simply the sample size. If you are doing the sampling with replacement, we are going to use the first formula, and if we are using sampling without replacement, so we are going to use the second formula. Okay, this question will make you more clear. Population consists of n, capital N is equal to 6, which is population size, numbers 0, 3, 4, 6, 9, and 15. Drawn, draw all possible samples of size 3. Now, this is new for us because before this we have studied, or we have made the samples of size 2, but here we have to make or construct the samples of size 3 without replacement from the population, and find the sample proportion of even numbers in the sample. Construct the sampling distribution of sample proportion and verify that mu p cap is equal to capital P, and variance, this is variance, VAR means variance of p cap, is equal to this. So starting the question as we have done before, first of all you have to specify or write the population, then capital N, which is sample size, then small n, which is sample size, capital N, which is population size, and small n, which is sample size. And then the third step is finding the possible number of samples without replacement, as it was mentioned in the question that it is without replacement. So as I have discussed before, that the number of samples without replacement. For this we are going to use formula capital N C small n. So capital N is 6 and small n is 3, and when we compute it directly from the calculator, this is 20. So total number of samples is 20. Now it is without replacement, and we have to make the samples of size 3. So first sample, we just see here, first sample is 0 3 4. 0 is not repeated, 3 is not repeated, and 4 because it is without replacement. So 0 3 4 first sample, then 0 3 6 second sample, then 0 3 9 and 0 3 15. After this we will leave this 3 and we will go with 0 4 6, 0 4 3, 0 4 15, and up to so on, and after that 0 9 15, and then we will leave this 0 and start with 3 4 6, then 3 4 9, and up to so on. And then proportions. Now we have to find the proportions of even number. It was mentioned here, it is mentioned in the question that sample proportion of even number. So 0, here we will consider 0 as even number. So proportion is in the form of fraction. So there are two even numbers, 0 and 4, and total are 3. So 2 by 3. Then again 2 6, 0 6, so there are two even numbers, so 2 3. Then in third there is just one even number, 0, so we will write 1 by 3. Then again here 1 by 3. Here all three are even numbers, so 3 by 3, and up to so on. We will find the proportions in the same way. After finding the proportion, we will compute the sampling distribution of p cap. And sampling distribution, first we will write all possible values of p cap in first column. So the possible values are 0 by 3, 1 by 3, 2 by 3, or 3 by 3. There is no other value other than this. So these are all possible values. Now we will write the frequency. Again, I have told you about the frequency, that frequency is number of occurrence. So 0 by 3, or 0 occurs just once. Here you can see 0 occurs just once, so I have written 1. Then 1 by 3 occurs 9 times, 2 by 3 occurs 9 times, and 3 by 3 occurs only one time. So I have written here. And again, because the possible number of samples is 20, so when we add the frequency, it should be 20 here. Now the probabilities. So probability is number of occurrence divided by total frequency. So 1 by 20, 9 by 20, 9 by 20, 1 by 20, and when you add these all, it will always equal to 1. Now for the mean and variance, we have to construct these two columns. First column is p cap into probability of p cap. We have to multiply this column with the first one, and when we multiply anything with 0, it becomes 0. Then 1 by 3 into 9 by 20, it is 9 by 60. Then 18 by 60 and 3 by 60. And when we add them all, the answer is 0.5. Again, for p cap square into p of p cap, we have to take square of this and then multiply with probability of p cap. So 0 square will be 0. Then we have taken square of this and multiplied with this, so it is 9 by 180, and up to so on, and the final answer or final sum is 0.3. Now we have to verify the properties. So first property is mu p cap is equal to mu. As we have discussed the properties before, so mu p cap is equal to capital P. So here mu p cap the value of mu p cap is equal to summation p cap into probability of p cap. So here we have constructed this column, and we have added this column. So the final answer is 0.5. So this is 0.5, and now p cap is the population proportion, and in population we will also see the proportion of even numbers. So this is our population. So when we see the even numbers, all the population items are 6, and 1, 2, 3 are even. So then here I have written 3 by 6, which is equal to 0.5. So first property is verified here. Then second property is variance of p cap is equal to this formula. Now, for variance of p cap, formula is summation p cap square into probability of p cap minus summation p cap into probability of p cap whole square. So in the previous slide, I have calculated this summation p cap into probability of p cap and p cap square into probability of p cap. So I have put here values, and after computing this left hand side, we get the final answer 0.05. Now, right hand side is p into q by n, and n minus small n minus 1. Now, the value of p is 0.5, and the value of q is also 0.5, because for q we subtract the value of p from 1. So if we minus 0.5 from 1, so we get 0.5 again, divided by 3, and 6 minus 3, which is n, small n is 3 and capital N is 6, and 6 minus 1. So when you solve it, you get the final answer this, which is equal to the left hand side. So it is proved and verified. This is all for the sampling distribution of sample proportion p cap, and this chapter is also finished. Now in next lecture we'll discuss the last chapter, or the last portion of the course, which is statistical inference. Thank you very much.